Hello everyone, Brian Weigel here, and in this video we will discuss data analysis, in particular descriptive statistics and creating charts. Here we go. On our agenda for this presentation is a brief introduction about what we're doing and why, and then I'll discuss IBM SPSS and how to create descriptive statistic tables that could be useful in a number of different data analytics. We'll then export that data file and import it into Microsoft Excel, where we'll talk a little bit about organizing your data set, in particular using formulas to insert columns of percentages and organizing it in a way that you can create effective charts. We'll then create charts using Microsoft Excel. Before we begin creating charts and descriptive statistic tables, or before we can analyze and compare our data in, say, clustered bar charts that we produce in Microsoft Excel, I first assume that you have a database that you're working with. In this case, we're using archaeological lithic data from a late Pleistocene site in Alaska, so years of lab work have gone into creating the database using Microsoft Access and collecting the data in a very standardized way. Now that I'm confident that my data set is thoroughly manicured and in good shape, I will export that data as a text file or as an Excel file, in which I could then import into IBM. While you can use these methods on any kind of a data set, we will be using archaeological lithic data collected in an archaeology lab to generate descriptive statistics, also discuss organizing data, and then creating comparative charts. In order to create tables of descriptive statistics or to run basic statistic analyses, we're going to use IBM SPSS. In SPSS, we first have to open file and import data. In this case, I'll be importing a CSV text file, but you may choose to import a single Excel spreadsheet. Whichever your file type, it will open the read file function, which gives you a series of options. I'll be selecting the first line contains variable names because that's where my attribute names are. And I'll also be removing leading spaces so that the database is in good shape. Once I've successfully imported my data set, I'll go to the top line and select Analyze. And from that drop-down list, I'll be choosing Descriptive Statistics, and I want the Crosstabs function. So Analyze Descriptive Statistics, then Crosstabs. In the options for Crosstabs, I'll be selecting Axis and Cluster attributes in this window. My target list will be Component. Because it's archaeological data, everything is relative to the number of different attributes that you find in each component or occupation layer. So I want to compare different components which have wildly different numbers of lithic artifacts in them to each other. And in order to do that, I want to show the data as percentages. So as I'm setting this up, I want the percentage of each attribute within each component, not comparing it across the entire lithic collection. That way I can see how things changed through time. With 7 different components in there and multiple different attributes that were collected from the sample, we have a lot of options to work with. So under target list, I'll be selecting component, and under columns, I'll be selecting all the different attributes that I want to compare. In this case, artifact category, artifact type, and so on. In the top right corner of your Crosstabs options is a button for statistics. Here you can open dialog where you can generate chi-squares or other statistical analyses that may suit your needs. So here you can select the options chi-square, or you can also select to display clustered bar charts in the SPSS output. We won't be selecting any of these options because we're only after the tables, the cross-tabulation tables with the raw numbers in them. We will then be exporting those charts into Excel, where we'll use Excel to make the charts. But you can also make charts in SPSS just as easily. Either way, you can use the statistics options for deeper analyses. Now you should have a series of tables that give you the processing summary of all of the attributes that you've collected. In this case, you can see that there are 4,790 lithic items in my entire database, and those are subdivided into different components. There are 7 different components among the assemblage, and each component has wildly different numbers. For example, component 2 has over 3,000 lithic items in it, the bulk of the entire collection. So in order to look at these comparatively and to make sure that we're actually comparing apples to apples instead of apples to oranges, I want the percentage of each of these attributes within each component line. So while there may be only 17 items in component 1, I still want the percentage of debitage or FCR or microblade or whatever your attributes are within that line. So now we have to review our data output, and if you notice, all we have are the numbers, and we want to deal with percentages. So in the next case, we need to export the data into a format that we can use in Excel or Microsoft. So you could either export these into a different file itself and then open that file in Excel. I'm just going to copy the block or the table and paste it directly into Excel, making sure that the numbers paste and not a picture. And now I have nice cross-tabulation tables in Microsoft Excel, where we will talk about data organization, creating formulas to help you quickly calculate percentages and totals, and then creating charts and inserting them. So I've just included all of the different crosstabs in one sheet to make it easier to work with, and so that I'm not constantly toggling between different workbook sheets. So that's the first step in organizing my data. The next is I've just kind of cleaned it up, removing unnecessary cells. SPSS has provided us these raw numbers, but we want to add columns that represent percentages for each of these. In order to better organize my data so that I can more easily create charts, I need columns of percentages. And in this case, I want the percentage of each attribute in relation to the component line. So I'll be dividing the cell with the number by the total number within that component, not the total number of the entire assemblage. So for component 1, I want 3,076 debitage pieces divided by the total number of artifacts in component 1 at the end of the sheet. So you can see the formulas I've typed in here. And in Excel, you can then drag those down by clicking in the right bottom corner of the cell and then dragging it down, and it will automatically populate these formulas once you put the first one in. And you will very quickly then create a ratio that you can convert easily to a percentage simply by formatting these cells as a percentage. Here you can see how I've used the tab under Home on Excel to format each cell that I needed to be a percentage, and I also used this to set the decimal space so that my data is represented in a way that is most effective. I have a lot of data that is less than 1%, and so I chose 1 decimal space for my data sets. And you can also see an example here of where I've entered a formula in the formula bar to calculate the percentages that I need. I also then use the auto populate function in Excel, where I drug the bottom right corner throughout the cells that I needed those formula replicated. And Excel is very good at knowing the formulas and reading the cells and interpreting what you need. Next, I'm ready to select my data to build my first chart. In this case, I'll be only using the artifact category. And so these shaded cells here are the data cells that I'll highlight. Note that I'm including the column header, which will group the data together. Do not include the totals. All you're selecting are the shaded cells here, shaded in gray. These are the data that I'll use to create the first chart, in this case, attributes on artifact category by a select number of components. Now that I have my data selected, I'm going to select which chart I want. In this case, I'll be selecting a clustered bar chart, but you may want a different kind of chart. Now that we've inserted a chart, we can use the chart editor to format the appearance of our chart. I've applied a chart template here of one that I created previously and saved. You can go in and individually change the colors of different variables, change the font, change the axes so that they read at 100% as opposed to 70 or 120%. You can also change the decimal places and manipulate the settings on the properties of almost every aspect of this chart, changing its appearance so that it looks the way that you want. Now that I've created descriptive data charts for each of the different attributes that I had in all of my different components, I've used the chart editor to make the charts look the way that I want so that they are relatively uniform and all the variables are color-coded in the same way, and I have my percentage access set to 100%, I can now begin to go through and analyze this data and interpret it in a way that is visually appealing and relatively easy to disseminate to other people using my charts. Thank you for tuning in, and I hope you found this video particularly useful.